Hello everyone, welcome to the lecture series of operating systems. So in last class we have seen about the topics Introduction to Operating Systems and the storage devices present in our computer. And then we have also seen about the operating systems operations. So today we are going to see about the functions of operating system. So on the screen you can see what are the different types of functions that operating system is going to perform. So it is going to perform the process management, memory management, file management, cache management, security management and command implementation. So now let us see what in detail about all these functions. So the first function is the process management. So what actually is a process? So the program which is written by us, so when that program starts executing, so that program which is in execution is known as process. So execution in the sense your program instructions will be loaded into the CPU. So these process, there may be number of types of processes present in your computer. That may be a word processor, that may be a user process or a system process. So a user process may be those processes which are the user applications or the application programs used by the user. Whereas the system programs like printing an output through the printer. So whatever the process may be, in order to execute a process, the operating system will provide many activities in order to manage these processes while they are executing. And you can see on the screen the different activities what the operating system is going to perform. So first thing, right from the start of the process to the shutdown of the process, the operating system will keep on maintaining it. So it also creates a process, deletes a process from the execution, it suspends and resumes the process. Suspending in a sense pausing the process. So when you need to pause a process, say for example you are executing some program and at the point of time when you have to take the input from the user, the CPU will remain idle until the input is given by the user. At that time, the process or the program which is being executed in the CPU will be suspended, and then the program control will be moving to the particular resource in order to take the input. Once the input is given, the process again resumes its execution. So that management is also done by the operating system. So it also provides mechanisms for process synchronization. So what is this synchronization? When two processes comes for the execution to CPU at a time, there should be some order of execution or there should be some synchronization between these two processes. So that is also managed by the operating system. And lastly, it also provides the process communication. So why two processes need to communicate? Because in order to say for example you need to give the output of a program to the as an input to the next program. So in that case these two processes need to communicate with each other. So that communication is also provided by the operating system. And then we have the memory management. So you have seen in the last lecture, you have seen all the different types of memory storage devices present in our computer. And we have discussed that CPU has only the direct access with the main memory. So as the size of the main memory, the storage capacity of this main memory is very less, we need to replace the applications, the data of the applications that are being executed from the main memory. And all these operations will be managed by the operating system. So on screen you can see the activities of operating systems regarding to the memory management. So the operating system will decide which process has to be loaded into the main memory and which what amount of space should be allocated for that application or the process. So it also allocates and deallocates the memory space as needed. So if the RAM is full of already executing applications, and if you want to execute one more application at a time, then the operating system will manage which process to be deallocated the memory. It checks what is the process that is being leastly used and removes the data corresponding to that process and then gives the memory space for the newly executing application. And then third, we have the keeping track. It also, the operating system will also keep track of which parts of memory are currently being used and by whom, that is by which process. And it also decides which process and data has to move into the memory and has to taken out from the memory. It also manages the allocating and reallocating memory space if needed. And the next function we have is the file management. So as you all know, what is a file? It is a collection of related information. So who is the one? The user will create this file. Okay. So with that, we are already discussing that there are multiple users who are going to use your computer. So in that case, if a user is creating some files, and that files should be protected from the remaining users who are using that same computer. So in that case, the operating system will provide the access controls towards the files created by the users. So it also allows the users to perform tasks like creating and deleting files, creating and deleting directories, that is the folders, and it also supports primitives for manipulating files and directories, mapping files onto secondary storage. So what is this mapping in the sense? We already discussed, if you want to open a file, that file also should be loaded into the main memory. In that case, so this when you are saving a file, normally if you already written some file, already written some data in the file and saved it, so that data, that file will be saved in the secondary memory. So once if you want to open the file again and edit some text, so in that case, the file which is stored in the secondary storage device should be loaded into the RAM and then to the CPU. So while loading this file from secondary storage to primary storage, the operating system will manage what are the memory locations present in the secondary storage device for that particular file. So what amount of memory is needed for that file in order to load into the main memory. Okay, so all these mapping in the sense mapping the addresses of these secondary storage devices into the towards the primary storage device. And then lastly, we have the backing up of files on stable, that is stable storage device. That is when we have an when we have an opportunity, like if we are going to lose the data, if you have a doubt that you are going to lose the data, your operating system will try to keep a copy of your data without losing. So that copy, extra copy of data is called the backup data, and that can also be done by the operating systems. Then we have, after file management, we have the cache management. So already we have seen about the memory management, and the cache is also some memory device, right? So why again this cache management? It is because, as you have seen, the memory of the cache is very less. It is you will be seeing the chat. So it is less than 16 MB. So in that case, we are placing those instructions which are being repeatedly used or repeatedly executed in the cache memory. And if this cache memory is not managed, so if the operating system does not take care of what are the instructions to be placed in the cache memory, the system performance may degrade. So in order to, by maintaining this cache memory, by keeping track of what are the instructions to be placed in cache memory and what are the instructions to be taken out from the cache memory, your operating system will improve the performance of your computer. So here performance in the sense, as soon as you try to open or execute an application, the system will make that task with faster access. Okay, so for instance, if there is no cache management, your CPU should wait for several number of cycles in order to execute a single instruction. So in the diagram you can see the levels or the levels of storage devices in which your variable or data value is going to pass from each and every device. So from magnetic disk, that is the secondary storage device, if you are saving some integer value in a program, So that value is first saved to the magnetic disk, that is your secondary storage. From then it is moved to main memory, from main memory to cache memory, and then to the actual registers present in your CPU. Now let us see the chart of the storage devices, how they are going to work out and where they are being managed. So you have different types of storage devices like registers, cache, main memory, and solid state disk, that is nothing but your electrical disk and the magnetic disk. The second row, the typical size indicates the storage capacity of each device. Implementation technology, where these devices are actually implemented in your system. Access time, so access time in the sense the time taken for each instruction in order to load it from that particular device towards the CPU. Okay, if you observe this access time, the access time is very less for registers and it is more for the secondary storage devices. That's why CPU will try to fetch instructions right from the main memory itself. And then bandwidth. So bandwidth, if you observe, registers have more bandwidth. That is, as the access time is small, more number of data can be transmitted per second. And then these are managed, registers are managed by compilers, cache memory is managed by hardware devices present in your computer, and main memory by operating system, and the remaining secondary storage devices also by operating system. And the backup is stored in different devices as you see on the chart. So then we have the protection and security management. So protection in the sense controlling the access of process or files from other users. Whereas security in the sense protecting your computer from other malware or programs present in your computer. So this protection will improve the reliability by detecting the errors and interfaces between the subsystems or the different users. Whereas security is done, if you observe, when you are trying to download something from the internet, if you are trying to download a file, so sometimes you will be given a message like this file may harm your computer. Please, do you want to keep or discard? You will be getting some messages like that. So those messages are also given by your operating system in order to warn the user that downloading that particular file may harm your system. In that way, it provides security to the computer. So the activities involved by the operating system in order to provide the protection and security for users are: it provides alert messages, it provides dialog boxes, it also gives the firewall. Firewall in the sense, the firewall is a program which protects you in order to download a particular site in your computer. And it also provides security by giving you passwords and restricting the remaining users in order to access your data. And then we have the command interpretation and user interface. The command interpreter is an interface between the system and the user. So whatever the task you are going to perform in a computer, you need to give that command. You need to give a command in order to perform some specific task. And say for example, most of you are using Windows operating system. So while using Windows operating system, if you want to open a file, so what you are going to do, you're just double clicking on the file icon with your mouse. So the operating system will convert this action into a command and indicates the hardware of the computer in order to give access to that particular memory where the actual file is residing. So in that case, the command interpretation is done by providing two interfaces to the user. One is the command line interface and the other is a graphical user interface. So through command line interface, the operating system will provide the user in order to give some commands to the computer and executes that particular command. Whereas in graphical user interface, it provides some graphical images like icons, images, and then labels. All these, with all these, it also supports the pointing device, that is your mouse. So the user can easily interact in order to perform some specific task. So these are the functions provided by the operating system. So thank you for watching. In next video, we'll see about the types of operating system.